What up, mathletes? Whoop, whoop. All right, let's do this Math 2 review for test 1. And here's how this works. All right, it says that JK is congruent to KMK. That means that this distance right here is the same as this distance. So if I want to know the whole distance of JM, it's just that 8.3 times 2, or I add them together, and I get 16.6. Right? All right, there we go. We're starting off quick. Let's keep going. Again, I'm assuming you're pausing this as we go, so just keep that in mind. Pause and then only look when you need help. G is the circumcenter. Circumcenter means this. It means that this side, GE, is congruent to GC, which is congruent to GA. Okay? Of triangle ACE. Find AE. So we need to find this whole distance AE. Well, here's the deal. To find AE, if I know that AG right here, or GA is 13.1, then I know GE is 13.1. And here's what I now have. I now have this triangle right here, which is, boom. Well, I guess I can just use this triangle, right? Which is, boom, 13.1, and this little length right here is 7.2, which we see right there. And let's do this. Here's what I know. If this is my A, this is my B, this is my 90 degrees, which makes that my C. It's always opposite the 90 degree. I know that my B is equal to the square root of 13.1 squared minus 7.2 squared, right? That A side. And so when I put that in my calculator, I get that this is approximately 10.9. So now that I know that this is 10.9, I'm going to multiply it times 2 because it turns out this side is congruent to this side. These are actually perpendicular bisectors. So when I multiply it times 2, 2 times 10.9 is 21.8. Boom, 21.8. Let's go. Love that circumcenter. All right. Again, if I go too fast, pause and catch up. True or false? G is the end center. Okay, if it's the end center, here's what I know. GE is congruent to GD, which is congruent to GF of triangle ABC, and the measure of angle DBG, this angle right here, is equal to the measure of angle EBG, right here. That's true, because in the end center, right, not only what it is, the end center is that point of concurrency of the angle bisectors, right? It's the end center. And turns out these are the same, so I can make one circle that goes around and touches all of those. So boom, yes, those are angle bisectors. We know it, we love it, we use it. This is true. Next on the list, we're just scooting through this. True or false? Oh, another true or false. In triangle QRS, the angle of the triangle ordered from least to greatest are angle R, angle S, angle Q. Okay? Well, I know it says from least to greatest. We want to start with the smallest. The smallest angle is directly across from the smallest side. So let's look. The smallest side is 6.75. So that would be angle R goes first. So far we're good. The next smallest side is right here. That's directly across from angle Q. Uh-oh. This is going to be false. I already proved it. And then this is across from angle S. There we go. This is false. Awesome. I don't remember what theorem that is, but I remember teaching that theorem. Ooh, now we got a centroid. I like centroids. Centroids are the 1/3 and the 2/3. In triangle ABC, G is the centroid, and AG, see AG, boom, just this little part right here is 22.4. Find the length of AE. Well, if this is 22.4, and I know this is 2/3, then I'm just going to divide that by 2. 22.4 divided by 2 equals 11.2. So this would be 11.2. Add them together, though, and I get 33.6. So add that to 22.4. 2/3 plus 1/3 makes 3/3. That's 33.6. Boom. And AE equals. All right. Another way you could have done this, guys, you could have just said, hey, if 2/3 x, so 2/3 of the whole equals 22.4, so multiply by the reciprocal, which is 3/2, right? That goes to 2, that goes to 11.2, and guess what 3 times 11.2 is? It's 33.6. Same thing, so just keep that in mind. More than one way to skin a cat. Okay, let's go to 6. What is the length? And again, I want to remind you, I'm assuming you're pausing this as we're going. Keep that in mind. What is the length of CD? So I want to know this length. Well, here's what I know. If, let's see, CDE, we'll call this F right here. If CF is congruent to EF, then I know that CD is congruent to ED. So I'm going to set up a nice little equation right here for myself. I'm going to say, all right, 7A plus 11 is equal to 10A, oh man, it's getting all bleedy, you know what I mean, plus 2. So I'm going to subtract 7A over, and I'm also going to subtract 2 over. And what do I get? That's gone. 11 minus 2 is 9. 10 minus 7 is 3A, so 9 equals 3A. Divide both sides by 3, and we get that A equals 3. Boom. So if I want to know the length of this side, that's going to be 7 times 3 plus 11, which is 21 plus 11, or 32. So we know that CD equals 32. Boom! Let's do this. This is a good problem. Okay, true or false? G is the incenter, so again I know GF equals GE equals GD. Triangle ABCD. Oh, true or false? Then GD equals GE equals GF. True. It's the incenter. And over here, if the measure of angle RQS equals 42.8, so that's RQS right here, then what's the measure of angle PQR? The same. It's an angle bisector, 42.8 degrees. Yeah. Okay. In a triangle, ooh, vocab, know your vocab. A blank line is a segment with endpoints that are on the vertex of the triangle in the midpoint. So, in other words, if we have a triangle, it starts from the vertex and it goes to the middle, that's called a median line. A median line. Any line segment or ray that passes through the midpoint of a segment and is perpendicular to that segment, well, that means here's a line segment, passes through and is perpendicular. That is a perpendicular bisector. Just is. Okay? All right, almost done, guys. In triangle ABC, G is the centroid, ooh, 1/3 and 2/3 again, and DC, that's the whole shebang, equals 36. Find DG and GC. Well, first I'm just going to say, all right, what's 36 divided by 3? That is, goes in there once, goes in there twice, 12. Boom. So right away, the 1/3 side, which is DG equals 12. And then what do I know the 2/3 side is GC. So GC equals 24, because together those add up to be 36, right? So this is the actual answer here. One more centroid problem. I actually like centroids. I don't know why. I just find them fun. In triangle RST, D is the centroid, and DB equals 18. Let's see, where's DB? Right here. DB equals 18. Find RD. Well, that DB is the short side, so that's 1/3. So just multiply that times 2. 2 times 18 makes that 36. So I know that RD equals 36 because it's the 2/3 side, right? And if I added them together, it would be the whole, which is... Oh, wait, does it want the whole RD? No, it just wants that part right there. Okay, got confused for a second. We're good. Awesome. All right, pause stuff, write it down. Want to look on the back. Here's things you need to know. What are concurrent lines? Those are lines that intersect. What are points of concurrency? They're that point where those lines intersect. What is a perpendicular bisector? Perpendicular bisector is a line that meets another line perpendicularly, and it bisects that line in half. And by the way, that's what the incenter is full of. So each of these are perpendicular bisectors that bisect those lines in half. An incenter is that point where angle bisectors, that's the same angle, this angle matches this angle, 1, 2, 3 matches 1, 2, 3, and it turns out these lines that are drawn perpendicularly from that point are all congruent to each other as well. It's called the incenter. And the centroid is this, such that the short side is 1/3 of the total. So if this total distance is x, then right here is 1/3 of x, and this is 2/3 x. Boom. And those are median lines. So that means they're actually separating this. You can't see in the picture real good, but it cuts these lines in half. 1, 2, 1, 2, and then 1, 2, 3, 1, 2, 3. Boom. Lots of special relationships, guys. This is amazing. Thank you for sticking with me. Crush this test. With that said, peace out.